So we're going to start our polynomials. Does anyone know what the prefix poly means? Well, 3 or more, like several, like a bunch, okay? So when you see something like this, 2a squared b cubed c, do you see a plus or a minus anywhere in there? No, it's all one thing, so we call that a monomial. Mono means one, it's a singular thing. I know it looks like there's a lot of stuff in there, but there's nothing being added or subtracted. Monomial, monomial, and that's not you. My handwriting is loopy. It's monomial. I can read it, but that's because it's my handwriting. All right, so when you look at this, do you see how there's a plus sign right there and a minus sign right there and another plus sign? You have all these things being added and subtracted. This is a polynomial because you're combining multiple monomials with plus and minus. So when you have the adding and subtracting is when it becomes poly. You have more than one thing, several. So when you look at this one, how many terms do you have? Terms. 2. Do you see how you have 5x squared and then you have 2y? You have 2 terms, so that is called a binomial. Bi like a bicycle, 2. So what do you think about this one? How many terms do you have in this one? 3. Do you see how there's the 5x squared and then the 3x and then the 2? They're all separated with plus and minuses. What do you think that one's called if there's 3? A trinomial. Like a tricycle. What'd you say? Well, technically it's a polynomial, but specifically tri for 3. Trinomial. All right. This has been written in what is called descending order. D-E-S-C-E-N-D-ing. Descending order. Do you see how there's the x squared? And then this would be x to the first. And then if it's missing, it's x to the nothing. So it goes 2, 1, 0, like it's getting smaller. That's typically how you see those written. And then like terms, which we're going to put together, have the same variables and exponents. They have to match exactly in order to be like terms. So what we're going to do here is basically just find all the ones that are the same and add and subtract them together. That's all that there is to it, okay? All right, so what we're going to do with this one, circle all the ones that are like terms with 3xy squared. So you have to find another one that is xy squared. It has to match exactly. So do you see one that's xy squared? Good, this one right here. Is there another one that has exactly xy squared? Yeah, this one right here, -1 xy squared. All right, but it has to match exactly for them to be like terms. Now there's a bunch of problems on here. We might not do all of them for the sake of time. You just need to do enough problems so that you understand what's going on. So looking at this first one, do you see this plus sign in between there? I usually use different shapes to group the like terms together. I would love to color code them, but the colors don't show up on this projector. So I'm going to use shapes. Do you see another term somewhere in there that is x to the third, x cubed? Do you see how those are the same? All right, I'm going to use a square for them. And you can go with the whole shapes thing if you want. You don't have to. As long as your answer's right, I really don't care, but just to group them together. So we're going to add those together. So hey guys, 4 plus 6. 10x to the third. We just added them together. Do you see another one that's an x squared? Yeah, do you see those? 2 and -7. All right, I'm going to use a circle for that one. So 2 and then -7. If you put those together, what do you get? -5x squared. And then once I get down to the end, I don't really need another shape for that because it's the leftover ones. You've got 4 plus 10, which is 14. It really doesn't, which is disappointing. All right, let's try another one. Look at this one here. Do you see another x to the third? Yes, we have 4x to the third. And then, now there's nothing in front of that one. So what is it really? 1. Good. So put them together and you get 5x to the third. Good. See, this is very difficult, right? It's just adding, all right? And then do you see this x squared in there? Do you see another x squared? No, so just keep it. It doesn't combine with anything. And then lastly, you have a -1 plus 10, which would be 9. Let's maybe just do one more of these. You don't, I'm not trying to torture you, just need to do enough problems so that you know what's going on. Let's do this one with all the m's in here, because this one looks kind of long. Do you see another m to the third?
Yeah.
Yeah, which one? Yeah, 2m to the third. All right, so add them together. 5 plus 2 is 7m to the third.
Job.
Hey, nice job using kind words. All right, then I would go to m squared. It's right here. Now, do you see another m squared? No, so just leave it plus m squared. If it doesn't combine with anything, that's the only one you have. All right, and then I would go to the m's. I'll use triangle for this one. We have 6m and then 2m, so put those together. 8m, very good. And then lastly, you just have the numbers, -2 plus 5, 3. Good. Are we all okay with that? Do you need to see another one or are we all right?
No, we're good.
Okay. Go ahead and flip over. These ones are subtracting. Please listen to me. Subtracting has one extra step where you distribute the negative sign. Do not be too proud to write out that step, because if you try to do it in your head, you're going to lose track of your negatives. Negatives are the most commonly missed thing ever. So just write the middle step, okay? Do you see how this is minus this time? Do you all see that there? You're going to just keep the first part, and you don't need the parentheses anymore. So just 3x plus 5y. Hey, Miss Cole, looks like you just copied that. Yep, sure did. Please stop that. And then you're going to take this negative and distribute it. What that is going to do is just flip-flop all of the signs. It's going to negate everything. They're all opposite now. So it will be minus 2x and then plus 9y. It's minus negative, so it would be plus, but you can just think of it as switching everything. Do you guys see what I did there? It's not hard, but you have to do it, all right? Now we're going to put stuff together. Do you see a like term with 3x? Good, -2x. So 3x minus 2x is 1x. And you don't have to put the 1, you can if you want to, that's up to you. All right, and then you have 5y plus 9y, which is 14y. All right, let's try it again. Do you see how this is subtraction right there? You see that? This first part, and you don't need the parentheses anymore, you're going to literally just copy it down and try to write kind of small because it's going to be really long. Like it's going to get, you're going to run out of paper if you write too big. So yeah, just copied that down. You're going to take this negative and distribute it through there. So all the terms are just opposite now. All right. So what would that give us? Good. Positive 2x squared, and then negative 7xy, and then positive 4. Perfect. It is just opposite. But what happens is people will try to do that in their head. And sometimes it works out, but more than often it doesn't, because you lose track of what's what. So please don't be too proud to just write it out. It's not that hard. All right. Now let's find our like terms. What goes with the 3x squared? 2x squared. So together,
5x squared.
very good. All right, we have a -1xy. You can put the 1 in there if that helps you. -1xy is going to go with -7xy. So -1 and -7. -8xy. Good. And then 5 plus 4, and it's 9y squared. We'll do a couple more. So I am going to do the one with all the fractions just because it looks scary. It's not actually any harder. Do you see how that's subtraction then? Yeah. You're going to copy down the first part. Again, start all the way off to the side because it's going to get like lengthy here. And I just copied that down. Hey, Miss Cole, it looks like you just recopied it. Yep, that's all I did. I'm recording this. And you're going to take that negative and distribute it through there, which again just means everything's going to flip-flop its sign. So you're going to have -2/3 x squared. And then what? +1/5 x. and then minus 3/4. Now, you can always use a calculator, but I think these already have common denominators. Yeah, they do. So it will not really be that hard. It just looks a little scary. 1/3 x squared. Do you see a like term with that? Which one goes with that one? Yeah, negative 2/3. Okay, so look, follow me on this. 1 minus 2. You have 1/3 minus 2/3. Good. 1 minus 2 is -1. So it's -1/3 x squared. When you have common denominator, you just combine it together. The denominator stays the same. All right, and then we got 3/5 x. What goes with that? Yeah, 1/5 x. So hey guys, 3/5 plus 1/5 is 4/5 x. And then you have -1/4 minus 3/4. -1 and -3. Good. Are you guys following that there? -1/4 and -3/4 would be a whole -1. It would be -4/4. All right, I'm not hearing complaining, so I'm going to assume that was okay. And then we'll do this one together since it's kind of long. Do you see the subtraction there? All right, you're just going to copy down the first part. Hey, it looks like you just rewrote it. Yep. You're going to distribute the negative into those parentheses. Everything's just going to switch its side. So it's minus 3x squared minus 4x plus 5y. Now this one's really long. Now look at the next part. Do you see how that's a plus? Nothing's going to change then. Just copy it down. Like you can distribute a plus sign, I suppose, if you want, but it's just going to be 2x squared minus x. It doesn't change if it's a plus sign. You're just adding it together. And then do you see this minus right here? You're going to distribute that into those parentheses. What will that give you? Well, it'll be minus 2x squared, and then what, guys? Minus 3x, and then good, perfect, but you have to write it. You can't be too proud to write it down. You can't be scared of writing. Like, you just can't be lazy, all right? Now, that looks really long. Let's go ahead and put the like terms together. Do you see anything that'll go with 8x? There might be more than one thing, actually. All right, we got -4x. Do you see any other just plain x's? Oh, good. And I'm going to put a 1 with that. Hey, can you focus for me? And -3. All right, let's add those up. 8 minus 4 be 4. 4 minus 1 would be 3. And then -3. Oh my gosh, what happened? They're all gone. 8 minus 4 is 4. Minus 1 is 3. And then 3 minus 3 is 0. Those are all gone.
Yes.
I know, right? Less work. All right. Now let's add up the y's. We have -2y. Do you see another just plain y? Yeah, we got 5y. And then 4y. All right, let's add those up. -2 plus 5 be 3 plus 4, 7. So 7y. And then everything I didn't circle or box in, those are all the same, right? They're all x squareds. So you have -3 plus 2 minus 2. So these will cancel out. So it's just -3x squared, and that's your final answer. So you took something that was that long and simplified it down. That's kind of the whole point, okay? And then let me see, let's do the number 19. In 1993, the average cost of a radio could be modeled by this equation. By 2006, the average cost had changed, so it's now modeled by this equation. So these are the two equations that you're looking at. Find the difference. What does the word difference mean? Subtract. So you're going to take this one, the -5t squared plus 1200. You take this one minus that one, because you take where you ended up minus where you started. So like you want the 2006 equation minus the 1993 equation. All right, so it's that one minus the other one. And again, you just can't be too proud to write it down. There's 2 more steps to this. I promise you'll be okay. Do you see this negative here? You're gonna copy the first part and distribute that negative through there. Everything is just going to flip-flop its sign. So that will give you plus 15t squared and then minus 1,000. And then you'll put the like terms together. What's gonna go with the minus 5t squared? Yeah, the 15, okay, so what will that be together? Yeah, 10t squared, and then you have 1,200 minus 1,000, which would be 200, and that's your final answer.